with graphing equations, with tables, graphing equations, with intercepts. So I just want to remind you about that real quick. So this is 3-1, graphing lines. Tables and intercepts. And since you've already seen this before last Wednesday, I'm just going to go through it really quickly and talk about what we talked about last time, because you haven't practiced it since last Wednesday. I didn't give you any homework. So if we're going to graph with a table, say we have something easy. Nice equation like this. 3x minus 5y is equal to 15. Now, if you're going to graph it with a table, there is a hidden direction. Does anybody remember what the hidden direction is?
0.
Nope. Solve for y first. So the hidden direction is always going to be solve for y. Okay. So if we solve for y, what do we need to move?
3x.
That 3x. When we move it over, it's going to become negative. So we'll have negative 5y is equal to negative 3x plus 15. Okay. Next step. Divide everything by negative 5. So divide everybody by negative 5. I like doing it to each individual term. That way I don't have to worry about the distributive property. All right, so we're going to get y equals. So try to write the fraction in front of the x. Be really careful how you write your x. If you write it too low, it'll look like it's 3 over 5x. So you want to write it kind of a little bit high and off to the right. Don't get it too close to this fraction. So you can kind of distinguish that it's a fraction is the coefficient, x is your variable. All right, minus, positive divided by negative here, 3. Okay. So if we're going to do this by table, what kind of values would you choose?
5.
Numbers divisible by 5, because that's the denominator here. And we only have to choose 3 of them. 2 to make a line, third one to check to make sure you did the first 2 correct. What's x called? Independent variables. Why? Dependent. They actually have other names, but we'll get into that later. So write this down as 3/5 x. Minus 3 goes in the middle. And what number do you want to choose first? Has to be divisible. Negative 5. Usually negatives are good to start off with and then work your way positive. So negative 5. The way I substitute in is pure parentheses for every variable. The format is actually much more important than what you're plugging in. So the 3/5 times something minus 3 is really important. Put the negative 5 in here. What does it become?
3.
No, it does not become 3.
0.
No, it does not become 0.
Negative 3.
This is 5 goes into negative 5 is negative 1. Negative 1 times 3 is negative 3. Negative 3 minus 3 is?
No, it's negative 6.
Oh my gosh. If I borrow $3 from you and borrow $3 more, I'm even. Yeah, darn it. Negative 6. All right, next number you want to pick. Easiest one in the world. 0. Always pick 0. So if you put in 0, you're going to get 3/5 of 0, which is 0. 0 minus 3, which is negative 3. So we get this coordinate 0, negative 3. Anybody remember what the name of that coordinate is? Nope. Origin is 0, 0. Which one? Y-intercept, because you're not off the x-axis, or you're off the x-axis and you're only on the y-axis. All right, next point. 5. Yeah, sure, why not? 5, 3/5 of 5 is 3. 3 minus 3 is? Now that's 0. What is that one called? When you have 5 comma 0? That's an x-intercept. So this one has a y-intercept and an x-intercept that we can find rather quickly. And then we just have to sketch it. Y-axis, x-axis. I always draw my y first because I have a hard time drawing a vertical line. Let's see. Biggest numbers we have here are 6. So 1, 2, 3, 4. You'll notice I make my 5 mark a little bit bigger than all the others. That way it's easier to count up if it goes to larger numbers. So I'm just going to go to 6. 1, 2, 3, 4, 5, 6. 1, 2. Probably the hardest thing is to make sure the spacing on these sketches are decent. And that's where graph paper comes in if you have a hard time spacing these things out. Okay. So just plot them in order. The first coordinate is -5, comma, -6. So where do I go?
5 down, 6 to the left.
No.
To the left 5.
To the left 5. X's are always left, right first. Y's are always up, down second. So you're going left 5 and down 6. So you start at the origin, and you go left 5, and then down to our maximum here of 6. So someplace right around here would be -5, -6. Again, this is a good place where graph paper is handy because it has those grids. All right, the next point is easy. It's 0, -3. No.
Down 3.
Down 3. It's 0 left and right, and straight down 3. So you start at the origin and you just drop 3. Like I said, those x-intercepts and y-intercepts are the hardest points for most people because they forget which way to move along the axes. And then 5, 0.
Go to the right 5.
Go to the right 5 and
0.
stop. Yeah, just put a point there. And these should, well, my grid must be a little bit off. But they should form a nice line that goes through them. What did I say about drawing a line? What are you really doing?
Little dots.
Lots and lots of little dots, an infinite number of little dots all along this path. For instance, if I chose x equals 1 here, what would you estimate the y value to be?
-3.
No, -3 is down here.
2 and 3/4.
-2 and 3/4. Yeah, we could estimate that. -2 and 3/4. So -2.75. It's possible. And we could find out. We could plug in 1 and see what happens. It would be 3/5 minus 3. Let me see, 3/5 minus 3. I'm just curious now. Minus 3, that would be 15/5. So that would be 12/5, which is about 2.4. -2.4. So it's a little bit low here, but that's okay. But they all exist in there someplace. So this is how you graph using a table. Now, any graph you can use a table to plot a bunch of points and see what the graph is going to look like. Any graph. You could graph things that look like y equals 2x cubed minus 3x squared plus 3. With a table, you'd have to pick a few more points because it's not a straight line anymore. It's a weird curve. You can graph things that look like things you don't even know about, but your calculator does. There's a little button on your calculator called something. You can plug in values, generate y values, plot points, and see what this graph looks like. So graphing with a table is probably the first step for graphing any new equation. We're just going to set it up in a table, plug in points, and see what happens. You never know. The other one was the intercept graph. Real quick, intercept. And also changing scales on a graph to fit our information. Oh, let's see. 4x plus 7y equals 280. Let's keep it kind of small this time. Now I'm being friendly because, well, 4 times 7 is 28. 24. And I'm going to always choose a number that both of them go into for intercepts. Makes life easier. So how do you find the most important intercept? Which actually is the x-intercept.
Solvable.
For y. When you're looking for an x-intercept, you're going to let y equal 0. Tori was holding up his hand back there. Just 0. All right, if you let y equal 0, the equation becomes 4x plus 7 times something is equal to 280 because we're substituting in for y. In the slot for y goes 0. We're choosing y to be 0. 7 times 0, of course, is 0 plus 4x. What property? Identity. So you get 4x is equal to 280. What property? What property? Nope. Inverse. So 4 divided by 4 is 1. 1 times x is? Property? Identity. Multiplicative identity, yeah. So you get x is equal to? 70. So this becomes the coordinate. X coordinate is? 70. Y coordinate is? 0. Yes, I'm going to pound property all semester long.
Why didn't we solve that like regular?
We-
Solve for y.
You could, but it's a waste of time. Because when you start plugging in zeros, it kills one of the variables and you're only left with the other one. So there's really no point in solving for y. You can if you want. If we're looking for a y-intercept, oops, what happens? The other variable is 0. And we start with the whole equation again. We're going to go 4 times, and since we're substituting in for x, we put some parentheses there. Plus, and since we're not substituting in for y, we'll leave the variable. And then equal to 780. What goes in the parentheses? 0, because we're killing the x. And then 4 times 0 is 0, 7y is 7y, and that's equal to 780. 780. 280. So 7 goes into 280? 40. So we get y is equal to 40. Okay. Now, if we're going to graph this, we're talking about 70 and 40. Am I going to mark it up by ones? That would take too long. I mean, I'd be there all day. How many? By what? 10. Yeah, 10 sounds good. I mean, 40 and 70, they're both 10s. So if we mark things up by 10s, here's 10, 20, 30, 40. Now, to make sure you indicate these correct, you have to at least mark one of them to give an indication of scale. So I'm going to mark this one out here. This is 40. If this is 40, then it took 4 marks to get there. The assumption is that it's 10 marks, or 10 in units per mark. All right, so let's see here. Oh, we got to go 70. Shoot. We have a problem. Houston, we have a problem. I didn't give myself enough room. So get rid of the 40. Let's see. 10, 20, 30, 40, 50, 60. There we go, 70. And then this one would be 80 way out here. You're going to run into those problems. All right, y is 40, so I'm just going to space it out a little bit differently. You can change the scale. That's a danger. If you see the newspaper and they have little graphs in them, there's certain graphs that can be misleading by just changing the scale just a little bit. They can show a great increase with like bar graphs, but there was probably very, very little increase over the time period. So you can lie with scaling, so be careful with it. All right, and you plot 70, 0, which is here, and 0, 40, this is 0, 40, 0 for x, 40 for y. 0, 40 would go here. And we'd have this nice line, this is a little harder to draw, that goes that way. Okay. Now let's elaborate on these two pictures. Do they share anything in common?
Straight lines.
They're both straight lines. What kind of points? Y and X intercepts. They both have intercepts. Okay. But what's the difference between them? Think stock prices. Which portfolio would you rather own? The green graph or the blue graph? The green graph. Why?
It's going up.
Because your stock prices are coming up. Over here, your stock prices are going down. They're tanking. So when we talk about, I like talking about it as stock because people understand that as the graph goes up, you're making money. This graph here is considered positive slope, the green one, because as you go from left to right, the graph is going up. It has nothing to do with it being down here in negative y land. The graph is going up as you move left to right. You read this like you read an English sentence. You move left to right and you see where the graph is going. The arrows have no indication of where the graph is going because lines go in both directions. So don't be looking at that. Just follow the path left to right. So this one is considered positive slope, also known as increasing. It's an increasing type graph. It's going up. Its value is increasing. This one is considered negative slope. I need a new marker. And this one is considered decreasing. The book doesn't talk about increasing and decreasing, but I think they better describe the picture a little bit better. So this is all 3-1 except for one small detail. This is what I covered last week. The one small detail is what happens if the lines don't have positive and or negative slope? What other two possibilities are there? If you don't have a positive or a negative slope, what kind of slope can you have? All lines are straight. Horizontal line is one type. If you have a horizontal line, your stock price is doing this, walking across the floor. What's it doing? Nothing. So what kind of slope would you associate with it? What kind of change is it making as time goes on? None, which was represented by what number?
0.
0. So that would be considered 0 slope. So let's talk about it. Horizontal lines. When you're talking about horizontal lines, it has this concept of 0 slope. Lose the word no from that sentence. You start saying no slope, that's totally different than 0 slope. So when we're talking about a horizontal line, we're talking about lines that are parallel to the x-axis. So lines that look like this. So let's say it has a y-intercept of, give me a good y-intercept. Yeah. 0, 4, 0, 3, something like that. So let's say this is 0, 3 as a y-intercept, and this is a horizontal line. It is neither going up nor is it going down. It's just staying rather flat. Then what would be a good coordinate for this point over here? 4, 3. Why are you not changing the second coordinate? Because it's not going up and it's not going down. So this could be 4, 3. What about this point over here? Well, it's a little further away, isn't it? Well, fine. Negative 5, 3, negative 4, 3, something like that. But notice what's happening to all the y values. All the y values are staying the same, constant. This is also known as a constant graph. So when I say, I have to be careful here. I better look at the book for 2 seconds. I have a habit of going way too far with some things. I guess I could do this. If you're going to come up with an equation for this line, what do you think it should be? What's changing? The x values, constantly changing. What's not changing? Y. Now remember when we do tables, we pick a bunch of x values and we generate a bunch of y values. But here the y values are always going to be same, which is 3. So when I write the equation for this, to make sure my table never changes, the equation just becomes y equals 3. And that way, if you plug in x equals negative 5, y is going to be 3. If I plug in x is 0, y is going to be 3. If I plug in x is equal to 4, y is still just going to be 3. Because there's no place to plug that x into. So so it doesn't change the equation. It's kind of weird. So if I wanted to graph y equals negative 5, how would you do it? I'll put it on the same graph.
Down to -5.
You'd go down to -5, someplace down here, and draw what?
Straight line.
All lines are straight.
A horizontal line.
You're going to hear me say that a lot. A horizontal line that just happens to go through -5. So this would be the graph of y equals -5. X can be anything you want it to be, but y is always going to equal -5. Now, I have a shortcut for this that the book never covers. My thing is, it's going to hit the axis that's labeled. If this is just one letter and one number, it's going to hit the axis that it's talking about. So this is going to hit the y-axis. Where is it hit it at? -5, and that way it has to go horizontal rather than vertical. Vertical would hit a bunch of y values coming up and down. So when we talk about a vertical line, what do you think the equation of a vertical line is going to be?
X equals whatever number.
X equals some number. X equals some number. So if we talk about vertical lines, what kind of slope does a vertical line have? Now think about this for a second. If we have a vertical line, let's say it's x equals 4. It's going to hit the x-axis at 4, and it's going to go up and down like this. Can this be the graph of a stock price?
No.
How can it be? I'm moving along. There is no stock right now. There's nothing. There's nothing. There's nothing. Then I hit this line. Which way do I go with my stock price? You don't know. It either goes up forever or down forever. So this has, it doesn't have zero slope. It doesn't have positive slope. It doesn't have negative slope. It has no slope. So when you say no slope, stay away from the word zero. This one means you cannot even associate a number, positive, negative, or zero, with this slope because it's neither going up nor is it going down. It's doing both at the same time. This is the reason you can't divide by zero. This is actually division by zero. It has two separate answers, negative infinity and positive infinity. And you can't have two answers with a mathematical calculation. I mean, 2 plus 3 is 5. It gives you an answer. But dividing by 0 gives you no answer whatsoever. Or it gives you two separate ones. All right, so if I give you x is equal to 4, this is your graph. It's going to be a vertical line. It's going to hit the x-axis. It's going to hit it at 4. So it gives you all the information. So if it's one letter and one number, it tells you what axis it's hitting, and it tells you where it's hitting it at. Then you just have to determine, is it horizontal or vertical? So these are probably the trickiest two lines going. And we'll talk about it a little bit more later when we actually talk about slope. All right. So now into 3-2 eraser. I'm going a little slow through this because I've taught this in college algebra for years and years and years. And for some reason, I'll teach it. Everybody will be like, yeah, this is easy, this is great. Then I give a quiz on it and they all fail it. Just graphing a line. Simple graphing, plotting a few points, drawing a line through it. And the biggest mistake is when I am looking for a positive slope, they give me a negative slope. Or they plot y-intercepts in terms of x-intercepts and x-intercepts in terms of y-intercepts. They interchange them. So there's a lot of silly little mistakes that people make. Plotting points. People have a heck of a time going left, right, up, and down. I don't know what it is. Maybe they can't walk and chew gum at the same time. So that's why I'm spending a little time with this, because this is extremely important for a lot of things in math. Drawing a picture that represents an equation is extremely important. So when we get to 2, we're really going to be talking about, if I remember right, slope. Now, I'm going to do it the book way. If you get me for college algebra, I do it totally different. So I'm going to follow the book for once, which is rare, and just define it the way they define it. They define slope to be m equals y2 minus y1 divided by x2 minus x1. now I got to define what they mean by all this mess. When you're in a, oh, did I ever name this thing? What do we call this thing? We have a y-axis and an x-axis. What's it called?
A chart,
The whole thing.
the graph.
Well, yeah, a lot of people say graph, but there's lots of different types of graphs.
Table.
No, tables are how we plot the graphs. I never gave you a name for this.
Algebra.
A line graph would just be the x-axis. That would be the line graph. But when you put the other one in, it turns into what's called a rectangular coordinate system. Or Cartesian coordinate. You never heard of either of those? Rectangular coordinate system or Cartesian coordinate system. So my question is this: are there any other types of graphs?
Oh, I guess so.
I guess so too. Actually, that little device down there in the corner uses a different one. It uses what's called polar coordinates. Polar coordinates, instead of having rectangles, has a bunch of circles. And what it does is, to find a point in a polar graph, it finds the distance away from the origin, and it finds, remember geometry? Angles, radians, something like that. And it finds its distance off of an angle. So when I push this pen down here, that thing is measuring how far away it is and how far off the bottom of the board it is. And it plots it in the right place on my screen over there, which is kind of cool if you think about it. But rectangular coordinate systems are taught because they're the very, very easiest of all graphs. All right, so when I talk about x1 and x2 and y1 and y2, what we're really talking about is any 2 points in a Cartesian coordinate plane or rectangular coordinate system. Any 2 points. They don't have to be here. Oh, what quadrant is this? What's it? Just draw a C, and that way you can count through it. This is 1, 2, 3, and 4. So these could be any 2 points. Generally, you label the first one as x1, y1, and the second one as x2, y2. What do most people do? For some reason, they'll put x1, x2 here, and y1, y2 there. Be careful. Coordinates are always an x-coordinate and a y-coordinate. So this has to follow the same pattern. And between these 2 points, between any 2 points, is a line. So when we write this formula, we're trying to describe the slope of this line. In this case, I've drawn the slope to be positive, negative, 0?
No, negative.
Negative, because our stock price is coming down. So to find a numeric value that represents the slope coming down, we're going to use this formula. The formula is great because if the line is coming down really steeply, the negative value would be kind of big. If the line is just very, very slowly coming down, the negative value is going to be kind of small. So it fits the information rather nicely. So for example, find slope of -3, 5, and 4, -7. I like mixing up all my negative signs, negative and positive all over the place. Why? Because most people make sign mistakes. They do silly things like -3 minus 3 is 0. That was all of you were. So, my suggestion when you're doing this, you have to concentrate on the y values first. When you're plotting points, you concentrate on the x value first and you go left, right, and up, down. Slope is backwards. Y happens first, x happens second. So I've done this several different ways, but if you're going to do the y's, I like doing that. Just put in a line of connecting the 2 y's on the top. It tells you 2 things. You're going to deal with the y's, and the y's are going to go on top. So what I write up here is 5 minus parentheses. You don't care what comes next, but it has to be 5 minus the next number. What's the next number? -7. And then I'm going to connect the x's in the bottom, and we're going to get -3 minus whatever comes next. I don't care what it is. But in this case, it's 4. Now, whether you write the subtraction up on top or on the bottom, it doesn't matter. So you can also write it here. -5 minus 7. I'm sorry, 5 minus a -7 and -3 minus 4. What's 5 minus a -7? Yes, Tori.
So
Come on, ask it. I know what you're going to ask. Go ahead.
So, it don't matter which way you use it.
Thank you, yes. It does not matter which order you go in. Because this point doesn't have to be x1, y1. It could be x2, y2. This one down here could be x1, y1. Also, the order of it, if I switch the top, what happens to the sign of the number? When you do 5 minus 2 and you switch it around and go 2 minus 5, what's the only change? The negative. So if I flip the top and the bottom, I'm going to get a negative over a negative, which doesn't change anything. So yeah, that's one reason I don't teach it by the formula, but I'm doing it here because the book does. But I hate it because people think this one has to happen first and this one has to happen second. It doesn't have to. If you want, you can kind of rewrite this. You can write it y1 minus y2 over x1 minus x2. There is no difference between them. The answer will be exactly the same. And that's another reason I like doing it, because working this way for most people is very difficult. I like going left to right personally. That's just me. But either way, you'll get the same answer. Someone could do it backwards. What's 5 minus a negative 7?
12.
12. Negative 3 minus 4? Negative 7. So when you write your answer, it's going to be negative 12 sevenths. So this slope would be down. It would be going down semi-fast. It's negative 1 and 5 seconds. Not think of it that way. But yeah, slope you can calculate either way. If you're more comfortable doing the second one first and the first one second, that's fine. But I suggest you just go left to right. How about something ugly? The book's going to do this to you, so I might as well get used to it. 2/3, comma, negative 1/4, and 5/3, comma, negative 5/2. Yeah, fractions, gotta love them. Now, should I make you work with fractions? Yeah. Or no? No, let's stick with working with them. So we're going to do the slope formula, which is y2 minus y1 over x2 minus x1. And just to keep my brain straight, because I make this mistake often, it's the y's first. So negative 1/4 minus whatever comes next. Negative 5/2 over, and then the x is next. It's going to be 2/3 minus whatever comes next. 5/3. Okay. Now, what do I need in the top? I need a common denominator. Common denominator between 1/4 and 5/2. 4. So I'm going to first change this negative negative into a positive. So this is negative 1/4 plus. Now what is 5/2 in terms of fourths? Well, to change the 2 into a 4, what do you have to do? Multiply by 2. To change if you multiply the bottom by 2, you better multiply the top by 2. You have to balance the fraction. You have to keep its equality. What's 2 divided by 2? 1. You're not changing its value. So that'll be what, 10/4? 10/4. The bottom isn't too bad. They're already common denominator. 2/3 minus 5/3. 2/3 minus 5/3. What kind of 3/3? Negative 3/3. What's negative 3/3 though? 1. Negative 3/3 is negative 1. So whatever happens, all I have to do is divide by a negative 1. So the top is negative 1/4 plus 10/4, which is?
Negative 9/4.
9/4 divided by negative 1. So this is 9/4, but it's going to be negative. It's 9/4 divided by negative 1. 9/4 divided by negative 1. So this is going to be my slope. Boringly enough, it's another negative slope. Must be one of my favorite types. Not bad, right? All right, one for you. Slope of -3, 5, and 2, 5. -3, 5, and 2, 5. 10 seconds. 10 seconds. That's all it should take. Y is in the top, X is in the bottom. They're different. They're different. Oh. 3, 2, 1. What you got?
0.
0. So what kind of line is this if it has a slope of 0?
0.
Because you're going to get 5 minus 5 over -3 minus 2, which is 0 over -5, which is 0. What kind of line? Horizontal. It's not going up, it's not going down. If you were going to graph it, what would the equation of it be? What's not changing? The y. So y equals?
-5.
Y equals 5. So the equation of this line would be y equals 5. Because it's going straight across, it hits the y-axis, and it'll hit it right at 5, because it's never changing. All right, how about this one? Another 10 seconds. -3, 5, and -3, -2. -3, 5, and -3, -2. Answer. Huh? No, you don't want to tell me what the answer is? Hard to describe, isn't it? It's not 0.
Is no slope.
It's no slope, but how do you define that? What do you say when you divide by 0? I know, but what do you say when I write things like, oh, this one would be 7 over 0 when we're done? Or -7 over 0 if we did it back. Undefined. This is undefined. So you have two choices with this type of slope. You either call it undefined or you call it no slope. I prefer undefined, so you stay away from that word no, which also associates with an answer of 0. What kind of change does it have? Well, it doesn't have change, so you have that negation in there. So it's better to call this undefined slope rather than no slope. But it is the same as no slope. What would be the equation of this line? The question always becomes, what's not changing? X equals -3. So this would be x equals -3. It'll go right through the x-axis at -3 and be totally straight up and down, a vertical line. So this is a vertical line. Vertical. Has no slope, has undefined slope. Undefined slope. All right, so that's vertical, horizontal, yet again in terms of slope. What time is it? Ooh, I still have time. This is awesome. I thought it'd be running out by now. What other kind of slopes can we talk about? If you were going to draw two lines in a plane, what are the ways you could draw them? I mean, you could draw them like this. Here's one line. Let's call it L1. And here's another line, L2. What would be the description of these two lines? They are definitely not perpendicular. They are what? Intersecting. The only thing you can say about these is they're intersecting. So I guess what's the opposite of intersecting? Parallel. So you can have two lines that are parallel. What's it mean to be parallel? Same. You mean the same line? Yes, that actually is one of the definitions of parallel. You can have the same line, but geometrically that's not true. Same what? What's it mean to be parallel lines, though? Two lines that go on forever and never ever intersect. Two lines that never intersect. Now, most people think of that as, railroad tracks. Two lines that are just offset by a constant distance between them. That's also a property of that. Can you prove that two lines are parallel? No. It's an assumption. You cannot prove it. If you were in geometry and they told you to prove that two lines were parallel, you'd have to be, assuming that they're parallel or something like that. There is no proof because they go on forever. So how do I know they don't lean towards each other someplace way down the line and touch? I don't. But it's assumed that they don't. So when we have parallel lines, this is L1 and this is L2, we can say something like, line 1 is parallel to line 2. Anybody ever see this before? I didn't misspell it. Anybody ever see IFF before? If and only if. This is if and only if, and let's say this one has a slope of m1. These are slopes. And this one has a slope of m2. What has to be true about the two slopes if they're parallel? They have to be exactly the same. m1 is equal to m2. If they weren't exactly the same, the two lines would lean towards each other on one side of it or the other. All right. Now, the if and only if is really nice. If my two lines are parallel, my slopes are exactly the same. If my slopes are exactly the same, then my two lines are parallel. It allows me to read it in both directions. Usually if you have an if-then statement, you can only read it left to right. If you have a square, then it is a rectangle. It's a true statement, by the way. But if you have a rectangle, do you always have a square? No. So it's only true usually from left to right. This one's true in both directions. So you can read it in this direction, or you can read it in that direction. If you're given parallel lines, you know their slopes are equal. If you're given two lines' slopes are equal, you know the lines are parallel. It goes back and forth. Okay. What other types of intersecting lines do we have that we talked about earlier? Perpendicular. This one's a little trickier. If you have perpendicular lines, here's line 1, here's line 2. What does it mean to be perpendicular? 90 degrees, also known as a right angle. There are two lines that intersect, so they're still intersecting lines, that form a right angle. All you need is one, because that forces all the rest of them to be also right angles. So, how do I know line 1 is perpendicular, that's a symbol for perpendicular, is perpendicular to line 2? What condition has to be met? Well, obviously the slopes are not going to be equal. And if you think about it, line 1 has a positive slope, very slightly positive slope. What's line 2 have? Slightly negative, well actually a very big negative slope. So this one has a small positive slope, this one has a huge negative slope. So I need to change one of the values from small to big and the other one from big to small. The only way to do that is to take a fraction and flip it. So the way the book writes it, I don't like it, but the way the book does it says m1, well this would have slope of m1. This one would have slope of m2. So these are also slopes. If m1 is equal to the opposite of 1 over m2. Personally, I don't like that one. I find it very confusing. The one I usually write is m1 times m2 is equal to negative 1. Oops, equal to negative 1. That one I like a little bit better. Only reason I like the product one is equal to negative 1. They're exactly the same, by the way. If you multiply both sides by m2, you get my equation. So they're exactly the same. The only reason I like mine is, if I tell you that m1 is equal to 5, you can set up an equation that says 5 times m2 is equal to negative 1. How do you solve for m2? Divide by 5. And if you divide by 5, you get m2 is equal to negative 1/5. Now there is a name that associates itself with those two numbers. What are they called? Not inverse. Negative opposite. Isn't that saying the same thing twice? What do you call it when you go 2/3 to 3/2? What's the name from 2/3 to 3/2? Reciprocal. And then they're changing signs, so you call it a negative reciprocal. So these are negative reciprocals. I'll probably spell it wrong, but that's okay. So when you're talking about perpendicular lines, you're talking about negative reciprocals. So if I give you a slope of 2/3, its parallel perpendicular would be negative 3/2. Its parallel would be 2/3. Would be 2/3. Would be exactly the same. Which one do you think people mess up the most? Parallel. Why? Because they think something has to change. In math, all the things that we do, you usually change it. Parallel tells you to leave it alone, and that's really hard for a lot of people to do. They think they have to do something in math. So be careful of that. So parallel, same slope, perpendicular, negative reciprocal slopes. Hey, look at that. Near the end of class. All right, homework. Those that didn't get their test back, stay for a few seconds. In 3.1, in 3.1, do all the practice problems. A lot of you left out practice problems in their homework that I've graded. So make sure you do your practice problems on one sheet of paper. Label it really nice at the top. It should say 3-1 PP at least, or practice. And then exercises on page 130.
One through one odd.
Yeah.